All right, imagine this. You've got this friend Joe, and Joe tells you this. He says, if Pete brings donuts to class today, then Jenny will bring beef jerky to class today. And you recognize right off the bat, oh my gosh, Joe has just made a conditional statement that I can symbolically represent using a horseshoe to join my two simple statements P and J. What I want to know now is Joe telling me the truth? So you look over at Jenny, you look over at Pete, and here's what you find. Pete's got an armful of donuts, and Jenny's nodding her head saying, check out all this beef jerky. In other words, both of our simple statements are true. Did Joe tell us the truth? I'm going with yeah. Because Joe said if Pete brings a donut, Jenny will bring the beef jerky. And Pete brought the donuts and Jenny brought the beef jerky. So I'm going to go with what he told us is true. Now let's say that Joe's still telling us about Pete bringing donuts and Jenny bringing beef jerky. And so we look over and we see that he's got an armful of donuts. So it's true that Pete brought donuts to class today. But Jenny's shaking her head and saying, sorry, no beef jerky. Did Joe lie to us? I'm going to say yeah. Joe told us that if Pete brings the donuts, Jenny will bring the beef jerky. And Pete brought the donuts, but Jenny didn't bring the beef jerky. So it's not true that if Pete brings donuts to class today, Jenny will bring beef jerky to class today because she didn't bring the beef jerky. So when the left-hand side of a horseshoe is true and the right-hand side of the horseshoe is false, the whole statement is false. Now consider this. You look over at Pete and he's empty-handed. No donuts. It's false that Pete brought donuts to class today. But it's true that Jenny brought the beef jerky. So now what we see is what appears on the left-hand side of the horseshoe is false, and what appears on the right-hand side is true. Okay? So if Joe has told us if Pete brings if Pete brings donuts to class today, then Jenny will bring beef jerky, and Pete didn't bring the donuts, but Jenny still brought the beef jerky, did Joe lie to us? And I'm going to go with no. I'm going to go with Joe told the truth. Now follow me on this. Consider this statement. If you earn 100% on all your Phil 12 assignments, then you will receive an A for the course. Okay? So here we have this statement represented symbolically like this. We'll say that E represents you earn 100% on all your Phil 12 assignments, and A represents you'll receive an A for the course. Now let's imagine this. You get to the end of the semester, you drop into WebAdvisor to see what your semester's grades were, and you see that you got an A in Phil 12. In other words, it's true that you will receive an A for the course for Phil 12. But you think to yourself, oh man, I didn't do 100% on all my assignments. He said, if you earn 100% on all your assignments, you'll receive an A for the course. I didn't earn 100% on all my assignments. I earned like 95% on all my assignments, or 90% on all my assignments. Okay? So it's false that you earned 100% on all of your Phil 12 assignments. But I didn't lie to you when I told you that if you earn 100% on your Phil 12 assignments, you'll receive an A. Okay, so I told you the truth. If you were to have earned 100%, you will have received an A, but that's not the only way to get there. Okay, so what we see here is that a horseshoe is true when the right-hand side, the J in this case, is true, and the left-hand side is false. Now consider this statement, or this set of conditions. So Joe has told you that if Pete brings donuts to class today, Jenny will bring beef jerky. And you look over, and Pete's saying, I didn't bring any donuts, and Jenny's saying, I didn't bring any beef jerky. In other words, both of our simple statements are false. Did Joe lie to us? I'm going to go with no. Okay? Joe said that if Pete brings donuts, she'll bring beef jerky, but Pete didn't bring the donuts. So I'm going to make sense that she didn't bring the beef jerky. And so here you have kind of a weird situation. There's only one set of conditions where a horseshoe statement is false, and that's when what appears, the statement on the left-hand side of the horseshoe is true, and the statement on the right-hand side is false. But all other combinations result in the horseshoe statement being true, even when both of the simple statements that comprise the compound horseshoe statement, conditional statement, are false. Kind of weird, right? So even when both of the simple statements are false, the conditional statement is actually true. And this represents the rule of conditionals. And again, it says here on line 2, the only way a conditional statement is false is when what appears on the left-hand side is true and what appears on the right-hand side is false.